let's go ahead and now do some examples on ellipses in section 10.3. So the first thing I want to do is to graph an ellipse. So let's go ahead and graph the ellipse with the following equation. X minus 1 squared plus 4y squared over 25 is equal to 4. So as we mentioned before, we want to make sure that there's a 1 on the right side. So if there isn't a 1, you want to go and divide both sides by that number. So we're going to force this to become a 1 by dividing by 4 on this side, by dividing by 4 here, and also on the right side. So on the left side, we're going to get x minus 1 squared divided by 4 plus this is going to become y squared over y squared over 25 is equal to 1. So the 4's are going to cancel. You take 4y squared over 25, multiply by the reciprocal of 4, and the 4's are going to cancel. So you get y squared over 25. And now we want to go and find what a is equal to and what b is equal to. In order to determine what a is equal to, find the biggest number in the denominator. The biggest number in the denominator is a 25, which means that a squared is going to be equal to that 25. So a squared is always going to be the bigger number in the denominator. So this is also going to determine whether my ellipse is longer vertically or if it's longer horizontally. So just as a reminder, if it's under the y, if the a squared is under the y, then that means that it's going to be longer vertically, just like on this picture here. So that means that b squared is just going to be the other denominator. So b squared is equal to 4. So in order to graph it, we're going to need to know what a is equal to. A is equal to 5, and we need to know what b is equal to. B is equal to 2. So a is going to be the distance between the center and the vertices, and b is the distance between the center and the points on the minor axis. So that's going to help me graph it. And then also we need to go and find the center. So in order to find the center, we need the HK, and this is based on whatever's next to the x and whatever's next to the y. So the center again is HK, and h is a number that's next to the x, and you take the opposite. Number next to the x is -1. You take the opposite, and that gives me a 1. And the k is the number that's next to the y, and you take the opposite. Well, there's no number next to the y, so we don't use that exponent, but numbers next to the y is 0, so then we're going to go ahead and just use a 0. So we're going to go and plot 1, 0. So if we plot 1, 0, we're going 1 to the right, and then 0 up or down. And then we're taking a is equal to 5. It was under the y's, so that means I'm going to go up by 5 units and down by 5 units, starting from the center. So this is 1, 2, 3, 4, and 5. So then my point, my first vertex is going to be at 1, 1, 2, 3, 4, 5. So 1, 5 is my first vertex. And my second vertex is going to be 5 units away, but going down from the center. So this is 1, 2, 3, 4, and 5. So 5 units away going down is now going to be same x value as the center, so 1. And instead of 5, it's going to be -5 because it's 5 units going down. And now we're going to use b is equal to 2. So this is going to give me the distance between the center and a point on the minor axis. So if I go 2 to the right, this gives me 1, 2. That gives me the point 1, 2, 3. So 3, 0. And if I go 2 to the left from the center, this is 1, this is 2, and that's at -1, 0. So my points are -1, 0, 3, 0 on the minor axis, and on the major axis, in other words, the vertices are 1, 5 and 1, -5. So this is vertex number 1, and this is vertex number 2. And then you go and connect these 4 points, making sure that it doesn't look like a diamond, so it has to be rounded off at the vertices and at these points as well. So let's go ahead and do another example. This time what we're going to do is we're going to write the equation of the ellipse in standard form. So I'm going to give you the equation in general form. Basically, I'm going to give you the equation that's expanded, and then we're going to take that and we're going to write it in standard form. So on this one, you want to write the equation of the ellipse in standard form. And in order to do this, just like we did before for the parabolas, we're going to need to complete the square. So we have 9x squared plus 4y squared plus 18x plus a 16y minus 11 is equal to 0. And we're going to put it in standard form. So in order to do that, what I'm going to do is I'm going to move any constants to the right side. So the 11 or negative 11 is going to be moved to the right side. Keep all variables on the left side though. So we do that because we want it in the form of x minus h squared over a squared plus y minus k squared over b squared, or this variation with b squared under the x minus h squared and the a squared under the y minus the k squared. The constant is going to be by itself on the right side, and then if needed later we're going to go and divide in order to get a 1 on the right side. So let's go ahead and move over that 11. We get 9x squared plus 4y squared plus 18x plus 16y is equal to 11. And in order to put it into one of these two forms, we're going to need to complete the square for the x's and also for the y. So let's go ahead and try to take care of that first. So in order to do that, I'm going to put all of the x's together, and then I'm going to put all of the y's together in order. So we have 9x squared plus 18x plus 4y squared plus 16y is equal to 11. When you complete the square, you want to make sure that there's no constant in front of the x squared or in front of the y squared. So that means I'm going to go ahead and take out the 9 from both of the terms that have an x. So we're going to take out a 9 from both of these terms, and we're going to take out a 4 from both of these terms. So that's one of the tricks. So we take out a 9 and we're going to get x squared plus a 2x. And then for this one, we're going to take out a 4, and we're going to get 4 times the quantity y squared plus a y squared plus a 4y. And this is equal to 11. So we still need to go and complete the square. So we're going to take 9 times x squared plus 2x plus something is plus 4 times y squared plus 4y plus something else is equal to 11 plus what comes from the x's plus what comes from the y's. So let's go ahead and do the one for the x's. So we're going to take 2 divided by 2. We're going to square this. This gives me a 1 squared, so this is equal to 1. You put a 1 on the left side. Now on the right side we need to balance it because we took out a 9. We need to go and multiply 9 times 1, and that's what we put in here. So 9 times 1 gives me back a 9. And you do the same thing for the y's. So on the y's, what we're going to do is we're going to take the b for the y's, which is 4, and we're going to divide that one by 2. So 4 divided by 2 squared gives me back a 2 squared, and 2 squared is equal to 4. So we put a 4 on the left side, but on the right side we need to balance, which means I need to take that 4 and multiply it by whatever I took out, which in this case was a 4. So 4 times 4 gives me back a 16. So on the right side, we put a 16. So again, this one was 4 times the 4. And we're going to go ahead and simplify the right side, and we're going to complete the square for the x's and also for the y's. So on the x's, we get 9 times a quantity with an x that's being squared, and in these parentheses, we're going to put this positive 1. So we're going to put a plus 1. And then for the y's, we still have a 4 on the outside, and then we have some quantity squared that has to do with the y's, and in these parentheses we're going to go ahead and put in this positive 2. So now it becomes a 4 times y plus 2 quantity squared, and this is equal to, if I simplify the right side, this is equal to 36. So we still don't have it in the form that we wanted in. So we're getting closer. We have quantity that's x's squared. We have a quantity that has y's being squared, but we don't have a 1 on the right side of the equation. So we want to go and make it equal to a 1. So in order to do that, we're going to divide this side by 36, and we also do the same thing for the left side. So we're going to take this and divide it by 36, and take this one divided by 36. If I divide by 36, I'm going to get x plus 1 quantity squared over 4, and then plus y plus 2 quantity squared over a 9 is equal to a 1. So this is my equation of the ellipse in standard form. Now if I wanted to go and graph it, I would need to go and find the center, and I would need to go and find the a squared, the b squared, and that's going to give me the a and it's going to give me the b. I know this problem is not asking me to graph it, but let's go ahead and extract that information just so we get practice. So the vertex is going to be hk, so the h value is going to be the number that's next to the x. You take the opposite. I see a +1, make it a -1. So the k is going to be the number next to the y. Take the opposite, that's +2. Take the opposite, that's -2. Vertex is -1, -2. So in this case, the one that's a bigger number is a 9. So that means that a squared is equal to 9. So if a squared is equal to 9, this means that a is equal to 3. Take the square root. And because a represents a distance, we're going to just take the positive square root. And then b squared is going to be the smaller denominator. Smaller denominator is 4, so b squared is equal to 4. So that means that b is equal to 2. Again, b is a distance. So a is a distance between the center and a point on the major axis. So it's the distance, oh, I said vertex here, it's the center. So the center is the x value, the opposite of the x, the number that's next to the x value, and variable, and the y value is just the number that's next to the y, and you take the opposite. So going back to the a and b, the a is equal to the distance between the center and the vertex or the vertices, and b is a distance between the center and a point on the minor axis. So then that means that we would go and plot the -1, -2, and then a is equal to 3. Because this came from the 9 and it was under the y's, that means that it's going to be longer going up and down. So this 3 is going to go up and down. So it's a distance going up and also a distance going down to find the second vertex. And for b equals 2, because it was under the x's, the minor axis is going to be parallel to the x-axis. So on this one, you're going to go left 2 and then to the right 2. And make sure that you're always starting at the center and then counting up 3, counting down 3, counting to the left 2, and then counting to the right 2. Alright, so I'm not going to go and graph it, but this is what you would do if you wanted to graph it. Let's go ahead and do another example. So on this one, we have, and let's use the same instructions as we did before. Write the equation of the ellipse in standard form. And for this one, we're going to also graph it. So let me rewrite it. Write the equation in standard form, and then also graph. Alright, so on this one, the center is at the origin. The major axis is of length 10, and the minor axis is of length 8. So let's go ahead and start drawing a sketch, and then we can use this in order to come up with the equation. So the center is at the origin. That means that the center is going to be 0, 0, which means HK is 0, 0. So center, which is origin, is 0, 0. And again, this is HK. So the H value is going to be 0, the K value is going to be 0. Major axis of length 10, minor axis of length 8. And I didn't tell you what the major axis is. The major axis is of length 10 on the y-axis. Otherwise, we wouldn't be able to graph this. So this is on the y-axis, which means that the minor axis is of length 8. This one's on or along or parallel to the x-axis. So if this is on the major axis, let's go ahead and graph the center of 0, 0, major axis of length 10 on the y-axis, meaning it's going to be longer going up and down. If the total length is equal to 10 from vertex 1 to vertex 2, then that means that the length of half of that is going to be 5. So I'm going to take that 10 divided by 2, and that gives me a 5. This is what's going to give me the A. So this gives me the total length of the major axis. So half of that is going to be the distance between the center and a vertex. So let's go 5 units up. And then we are going to go 5 units down. So this is a vertex. Vertex 1 is at 0, 5. And vertex 2 is going to be at 0, negative 5. 1, 2, 3, 4, and 5. And then the minor axis is of length 8. If the minor axis is of length 8, the total distance is equal to 8 from point to the second point on the minor axis, which means that half of that, which is 8 divided by 2, which is equal to 4, is going to give me the distance between the center and a point on the minor axis. So we're going to go 4 units to the right and 4 units to the left. So vertex number 2 was 0, negative 5. A point on the minor axis is 4, 0. And negative 4 is 0. And then we're going to go ahead and graph this, so connect these with the ellipse. And now we're going to go and find what A is equal to, what B is equal to, what the center is equal to, and put them all together in order to go and find the equation. So in this case, we said the major axis had a length of 10. Remember that the major axis has to do with the A. Minor axis is of length 8. Minor axis has to do with the B. So B is equal to half of that distance, which is equal to 4. A is half of the distance for the major axis, which is equal to 5. So if the longer length or the longer side is going up and down, that means that the A squared is going to go under the Y. So the general, or the form of the equation, not the general form, but the standard form, is going to be x minus h squared over b squared plus y minus k squared over a squared. The bigger number is going to go under the y's. The a squared is going to go under the y's. So this is equal to 1. And now we found that a is equal to 5. That means that a squared is equal to 25. We found b is equal to 4. That means that b squared is going to be equal to 16. So this is x minus h squared, and h we said was 0, k we said was 0. So x minus 0 squared over 4 squared plus a y minus 0 squared over a squared, which is 5 squared, and this is equal to 1. If we simplify, we get x squared over 16 plus y squared over 25, and this is equal to 1. Let's go ahead and do another example. For this one, we're going to do the same thing, so same instructions, and for this one, we're not going to go and graph it, so we're just going to write the equation in standard form. So let's write the equation in standard form. And for this one, we have a center at the origin. The focus is at 2 radical 3, 0. So one of the foci is at 2 radical 3, 0. And then the vertex is at 4, 0. So let's go ahead and plot this. So let's draw a sketch of this. So if the center is at the origin, that means that the center is at 0, 0. The focus is at 2 radical 3, 0, and then the vertex is at 4, 0. So let's say this is 4, 0, and this is 2 radical 3, 0. And again, this one was at 0, 0. So this is a vertex. We know that my ellipse, so right now I don't know what the length is going up and down. I know that the distance between the center and the vertex is at 4, 0 is equal to 4. So we can go and draw the same distance going to the left, but right now it doesn't really matter since I'm just going to go ahead and use this to determine what A, B, and C are equal to. So far, because the center, the focus, and the vertex are aligned horizontally, I know that the equation is going to go like this: x minus h squared over a squared plus y minus k squared over the b squared is equal to 1. So again, the a squared is going to be underneath the x if it's going to be longer horizontally. If it's longer vertically, the a squared is going to go under the y's. So how do I know what a, what b, and what c are equal to? So in this case, c is the distance between the center and the focus. So the distance between center and focus is equal to c, which is equal to 2 radical 3 minus a 0. So c equals 2 radical 3 minus 0, which is equal to 2 radical 3. We also know the distance between the center and a vertex. So the distance between the center and the vertex is equal to a. So that means that a is equal to the distance 4 minus a 0. So 4 minus 0 gives me back a 4. But what is b equal to? So there is a relationship that I haven't told you guys just yet. You can either use b squared equals a squared minus c squared, or you can use its variation, which is c squared is equal to a squared minus b squared. Both of them are going to give me exactly the same thing. So it kind of looks like it's like the Pythagorean theorem, except for instead of a plus, we're going to have a minus in between these two. So c squared is equal to a squared minus the b squared. So where does that come from? So the distance between this point, the focus, and this point, the point on the minor axis, is also equal to a. So if this is a, this distance is c, and this distance is b, then b squared plus the c squared is equal to a squared, which means c squared equals a squared minus b squared. So let's go ahead and plug in the c value, and let's plug in the a value in order to find b. So c is 2 radical 3, this is squared, equals a squared, so equals 4 squared minus the b squared. So this gives me back a 2 squared, that gives me a 4, and then radical 3 squared gives me back a 3, so 4 times 3, and this is 4 squared, so 16 minus b squared. So if I simplify, this gives me a 12, then you subtract the 16 from both sides, divide by a negative, you're going to get b squared is equal to 4, which means that b is equal to 2. So going back to this equation, we know that the center is equal to 0, 0, so it's at the origin. That means that hk, so we have b, and we also have a. In this equation, we don't have c, but we needed it in order to find what the b value was equal to. In this equation, we also need to know what hk is equal to, so let's go ahead and write it out also. So hk, which is the center, is at 0, 0. So again, we knew that c was equal to 2 radical 3 because that was the distance between the center and the focus. We knew that a was equal to 4 because that's the distance between the center and the vertex. But in order to write this equation, we're going to need b, which is why we're going to need to use this relationship, c squared equals a squared minus the b squared. So then once we find the b, once we find the a and the center, we just go and plug them into this equation. So x minus h squared is x minus a 0 squared over a squared, and a is equal to 4, so 4 squared plus y minus k squared, that's y minus 0 squared over b squared, so over 2 squared is equal to 1. Simplify, you get x squared over 16 plus y squared over 4 is equal to 1. And this would be my solution in standard form. So if you wanted to write it in general form, really the only thing you would have to do is expand everything and move everything to the left side. So that's what you would do if you wanted to write it in general form. Let's go ahead and do one last example. So in this last example, we have a focus at -1, 7, and we're still going to write the equation in standard form, just like we did before. But now we have a focus So focus is -1, 7, and my vertices are -1, 8, and -1, -2. So now I'm given two vertices, and I'm given the focus. Let's go ahead and draw a sketch of this. And this is going to help me determine which equation I'm going to need to use, whether the a squared is going to go under the x's, or is the a squared going to go under the y's. So it's going to be one of these two, x minus h squared over the a squared plus y minus k squared over the b squared, or maybe the b squared goes under the x's, or the a squared goes, and the a squared goes under the y. So let's go ahead and try to figure out which one it's going to be. So focus of negative 1, 7. So if I plot negative 1, 7, this is negative 1, 1, 2, 3, 4, 5, 6, 7. So this is my focus. Vertices negative 1, 8, so that means I go up 1 unit from this. So this is vertex number 1, negative 1, 8. This is the focus, negative 1, 7, focus number 1. And vertex number 2 is negative 1, negative 2. So this is negative 1, 1, 2. So the vertex number 2 is at negative 1, negative 2. So this is all aligned vertically. If it's aligned vertically, the a squared is going to go under the y's. So this is going to be a squared under the y's, and it's going to be b squared under the x's. So there's a few things that we're going to need to go and try to find. We're going to need the center. It's not given to us, but we can go and find it by what's given. We're going to need b, and we're also going to need to know what a is equal to. So in order to find the center, you have a few different methods. One is you can start out by finding out what a is equal to, and then use that distance in order to find that other point. Another way is just to kind of find the middle point between vertex 1 and vertex 2. So the center is always exactly halfway, and you can go and count, but sometimes it's kind of hard to do that, especially if you had fractions for these vertices. So what I'm going to do is something more mathematical. In order to find the point in the middle, we're going to go and find the midpoint. So the midpoint is actually the center in this case. So the midpoint is equal to x1 plus x2 divided by 2. So it's negative 1 plus a negative 1 divided by 2. So negative 1 plus a negative 1 divided by 2. And the y value is added divided by 2. So 8 plus a negative 2 divided by 2. So you might remember this from the beginning of the semester, x1 plus x2 divided by 2, y1 plus y2 divided by 2. So if we simplify this, we're going to get negative 2 divided by 2, that gives me a negative 1. So if we compare it to what we have here, to our picture, my center should be at x value of negative 1, and the y value is 8 minus a 2, which is a 6 divided by 2, which is equal to 3. So we're at negative 1, 1, 2, and 3. So if we go and find the distance between the center and the vertex, this is 1, 2, 3, 4, 5 going up, 1, 2, 3, 4, 5 going down also. So that gives me the same distance from the center to the vertex on top and to the vertex on the bottom. So the midpoint, which is a center again, is equal to negative 1, 3. So this is my HK. Now I need to find A, and I also need to find B. Well, we already kind of found A by counting, but if I didn't want to count, then what I would do is I would take half of the distance between the vertices. So what's the distance between negative 1, 8 and negative 1, negative 2? So the distance would be 8 minus a negative 2, and 8 minus a negative 2 gives me a 10. So the distance between this vertex and this vertex is equal to 10, and you take it and divide it by 2. So 10 divided by 2 also gives me a 5, which means that A is equal to 5. So whichever way you want to find that A value is really up to you. You can go and count once you find the center using the midpoint formula. You can go and count the distance, so or the units away from the center to the vertices, or you can go ahead and find the distance using the picture and find the distance between the vertices. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 divided by 2, and that's going to give me the distance from here to here and also from here to here. So A is equal to 5. And now we're also going to need B, but I don't have another point on the minor axis. Otherwise, if I had a point on the minor axis, then I would just go and find the distance between that point and the center. So in this case, I don't, but I do have a focus. Remember that the relationship between the focus and the center is that the distance between them is equal to C. So let's go ahead and find C first, and then we can go and find B. So C is equal to the distance between the center and the focus. So this is 1, 2, 3, 4. So C is equal to 4. So the distance between this point, negative 1, 3, and this point, negative 1, 7, 7 minus 3 is equal to 4. So that gives me, again, C is equal to 4. So now in order to find B, I'm going to need this relationship, C squared equals A squared minus B squared, which means that C is equal to 4, so 4 squared equals A squared, so it's 5 squared minus a B squared. And if you solve for B, you're going to get B is equal to 3. Once you find your A value, you find your B value, and you find your center, then all you have to do is plug it back into the equation. So the standard form is going to be x minus h squared. So h is negative 1, so it's x minus a negative 1 squared, divided by b squared. So b is equal to 3, so 3 squared, plus y minus k squared. So it's y minus a 3 squared divided by a squared divided by 5 squared. And this is equal to 1. Then simplify this. So this is x plus 1 squared divided by 9 plus y minus 3 squared divided by 25 is equal to 1. So this is the equation in standard form. Don't go and write it in general form unless the problem is asking you specifically to write it in general form. Otherwise, it's really easy to make a mistake going from here to the expanded form. So if the problem asks you to write it in general form, then you're going to go and expand this numerator, expand this numerator. You can go and multiply both sides by 9, both sides by 25, and then move everything over to the left side, combine like terms. So making sure that the left side is, you set the left side equal to 0. So 0 is going to be on the right side. So again, this one would be standard form.